All right, this is in the Algebra 2 book we're using in the year 2016. This is section 610, Properties of Logarithms, number 53. But this could be a useful video for any class, actually. One of the problems we had was 53A. It said evaluate 1776 to the 53rd power. If you were to put this in your calculator, the calculator would say overflow error. And the reason is it's just too big for the calculator to handle. It doesn't have enough memory. At least the old versions don't. I'm not sure about new versions of calculators, but I'm just going to assume it's too big for all of them. It says most calculators can't give an answer for an exponent more than 99. Maybe it would be better if I picked one bigger than 99, but even this one's too big. We can figure this out by using logarithms. When I first saw this, when I was trying to work this problem, I knew that at one time I remembered how to do it, but they tell us to use logarithms, so let's just try that. Let's say that we want to know what this number is, so let's call the answer that we want to get x. Now, I look at this, I don't know what to do with it. If I try to rewrite it, it is log ABC. It might help. One thing I can do, though, another way to accomplish this is to log both sides. If I log both sides, I have log 176 to the 53rd power equal log x. So this should look like log x over here. I'll write it since I kind of put that in and squished it in a little bit there. Now, if you remember, we can drop the exponent out front now, and we have log 1776 times 53 is equal to log x. Okay. So now, this 53 log 177x, I basically decided I was going to log base 10. And pretty much any time we do logging ourselves, we choose to do it in base 10 because then we can use our calculators. Well, if you put in log 1776, that by itself is about 3.2494. I'm going to keep the whole number in my calculator. I'm going to put ... but I'm going to put the whole number in my calculator to keep it as accurate as possible. Now, if I multiply this by 153, I get 172.220477. So I'm just going to keep as much as my calculator gets me, so I keep my accuracy there. All right, that's log x. Now, I don't want to know what log x is. I want to know what x is. So what can I do? What's the inverse of logging something? Log base 10, which is what I have here, its inverse would be to take both of those things, and let me write it on a separate line here. I would take both of these numbers and let them be equal exponents. And I'm going to put the 10 there just so that you can see that it is log base 10. These two things are inverse operations. They undo each other. So now I have x equal 10 to the 172.220477. Now, how does that help me? I have to remember that I know some things about exponents and exponent rules. I can split this exponent up into 10 to the 172 times 10 to the 0.220477. Let me come over here to work. Now I'm going to keep my 10 to the 172, and what this is going to look like when I get done is something written in scientific notation. Now this other part of it, which is hard to read because I wrote it, but if you're using your calculator and following along like you should be to follow through a problem on a video, you should not just be watching and writing stuff down. You should be working it with me as I go. I can actually get a number for that because the calculator can handle that. It's 10, so I can put this in my calculator, 10 raised to the 0.220477 power, and I get 1.6614. Okay, so what this normally would look like when we wrote our answer, we would write it, we can make it look like scientific notation. 1.6614 times 10 to the 172 power is what this value is. So I can actually make it look like that, and the good thing about that is that if I have other numbers, I can write them in scientific notation, and I can use those things to actually work with this number if I were actually to come up with it, even though it's too big for my calculator. Remember, with scientific notation, we can kind of separate out this x 10 to the 172 and put everything in scientific notation and combine those exponents that way. This actually is a way I could take this number and actually work with it and use it.